Okay, we have another optimization problem where we're trying to maximize the area. The statement says that you have an open top box is to be constructed by cutting equal squares of side and lengths x from the corners of a 20 by 25 inch sheet of metal and bending up the sides. So basically what we're doing is we're notching this out. We're notching out 4 squares and then we're going to bend them up. So we have some shape that maybe looks a little something like this. Let's see if we can draw this. And another piece that comes down like this. Another piece connecting it right there. So we have some dimensions here, like this is going to be 20 minus 2x, right? We cut out from this 20-inch side, we cut out an x and another x, so we subtracted 2 x's, and this long side here would be 25 minus 2x. So, and this is the height of x, right? Each of these heights as we bend it up. So hopefully you can see that graphically. And what does this mean? This means that, let's just take a look at it. These x's, if we set it equal to 0, 2x equals 20. So x can never be larger than 10, otherwise you won't have any dimension on this side right here, right? So the answer here has to be less than 10 and also greater than or equal to 0. Alright, so what are we trying to, we're trying to maximize the volume, right? So I suppose starting off with the volume equation, the volume equation would be x times 20 minus 2x times 25 minus 2x, and everything's in terms of one variable, so that's a fortunate thing. But in order for us to take the derivative, we are going to have to expand this out. So if we FOIL this out and simplify this, we're going to get something that looks like this. I'm going to get 4x to the third power minus 90x squared plus 500x. Okay. Yeah, that looks right. Okay, so the volume formula, it's here. And now we're going to take the derivative of volume with respect to x, and we're going to get 12x squared minus 180x plus 500. So this is a fairly large problem, and if we're going to set this equal to 0, or find the roots, in other words, maybe because this is so large, maybe we could use the quadratic formula to solve this for us. The opposite of b would be 180 plus or minus b squared minus 4 times a times c all over 2 times a. Okay. I've already done this. Basically, you plug this into the calculator to come up with the two roots, or the two critical values. We get 3.68 approximately, and the other one is 11.32 approximately. Well, if we look at these two values. This 11.32 is outside of our possible range, right? If x is larger than 10, then we don't have any dimension on that one side, so we can't have any volume. Okay, so it looks like the only possible value is 3.68. And we could plug this back into the original problem to find out the volume. In fact, that's what we're going to end up doing. But if we're going to maximize this, to the left of this, our endpoints are 0 and our other endpoint is 10, right? So if we pick a number like 1 and plug it into our derivative, we have 12 times 1 squared minus 180 plus 500. Well, 12 minus 180 is a negative 168. A negative 168 with a positive 500. Still going to be positive, right? And if we pick a number, say like 5, and plug it into the derivative, we get 25 times 12 minus 180 times 5 plus 500. Well, let's just see what that is in the calculator. Alright, just bear with me for a second. I'll crank this out real quick. We have 12 times 25 equals 300, and then minus 180 times 5 and that's a negative 600. Negative 600 added to my 500, of course, it's going to give me a negative 100, right? Oops. Didn't put enough zeros there, but you see that it's a negative 100. So we know that it's a negative right here. So this satisfies the first derivative test, telling us that we have an increasing function that starts decreasing after 3.68. So that's enough to tell me that that's a relative max. Well, to verify this thing, just to double check, let's go ahead and check the endpoints. The volume at 0, going back to the original equation right up here, of course you'd have 0 times 20 minus 2 times 0 times 25 minus 2 times 0. Well, anything multiplied by that 0 is going to carry out 0 the whole way, right? So clearly, if we make x equal to 0, it's not going to satisfy. We'll have no volume. And also, if we do it by 10, you get 10 times 20 minus 2 times 10. So this term is going to go to 0. And by the same reasoning, we get 0 on this middle term. 0 times any of the other ones is still going to give me 0. So in order for us to find the volume, we're going to have to plug in 3.68 times 20 minus 2 times 3.68. Run out of room here. Times 25 minus 2 times 3.68. And I think the volume is going to equal about 820, was it 0.53? And this was given to us in inches. So we have cubic inches for our volume. So that's our maximized volume based on this piece of 10 that we had originally. Alright, well, hope you followed through with that example, and when you try a few more, hopefully You'll pick up a few pointers along the way.